During the last few decades, with the rise of YouTube, Amazon, Netflix, and many others such as web service, recommender systems have taken more and more place in our life. For e-commerce to online advertisement, recommender systems are today unavoidable in our daily life. In a very general way, recommender systems are algorithms aimed at suggesting relevant items to user. In our project, we will go through two different book recommendation systems that we built. For each of them, we will present how they work and describe their theoretical basis. So first of all, we want to introduce the data and the features that we collect. The data source is from the Kaggle website, which is the Good Book 10K, thousands of books data from millions of ratings. There's 4 separate CSVs which documented including the information of books, the book ID, the tag ID, the name of the book, and the author of the book. To deal with the 4 different CSVs, we did some data cleaning. So the first step is to delete all the rows that in the book CSV where the language is not English. The second step is to get the tag names from each book. First, we group the tag IDs by using the book ID, and then we create a list of tag names for each book. Finally, we add a new column to the data frame that have already 8 other features that including the book ID, author, original publication year, original title, language code, average rating, and rating count. And here is the final dataset that we use. The first system that we use is the content-based recommendation system. The idea of content-based method is try to build a model based on the available features that explain the observed item interaction. Content-based methods suffer less from the co-start problem than other approaches such as collaborative approaches. For example, new book can be described by their tags, and so relevant suggestions can be done for these new features. Since we are working with item features, we use the user-centered method, which modeling, optimization, and computation is done by user. In our model, books are represented by given tags, and we try to model for each item the kind of book that was the top 10 cosine similarity. For example, Harry Potter have tags named with fantasy, young adults, fiction, series, magic, and etc. And for the Hunger Games, there's some similar tag names, for example, the young adults, fiction, and fantasy. So by using our recommendation model, when you input the name of the book, for example, the Hunger Game, our model will recommend 10 books that have the highest similarity of the input book.
Let's move on to recommendation based on network analysis. We use bipartite graph to model the situation, represent each user and the book by a node, draw a link from user A to book B if user A has read book B. Our main idea is that a book is relevant for me if other similar people like it. A person is similar to me if they like books that are relevant to me. To recommend books for user I, our algorithm contains 4 parts. The first step is to calculate the number of shared nodes between user I and user J. The second step is to calculate the user similarity score, which is the number of shared nodes divided by the total number of book nodes. Then, find the user J having the highest similarity score. The last step is to identify books that the user J has read but the user I has not read. Take user U6741 as an example. We found her most similar user was U4929A and recommended the book as following. For model evaluation, there exists one column of book ID, which is the books marked to read by the user. We use this as actual value. Correct means the books we recommended are the books marked to read by user. Our accuracy is defined as the number of users having correct recommendation divided by the total number of users. For a network-based model, we randomly sample 500 users from dataset, and the accuracy is about 61%, while the accuracy of content-based model is only 30%. The last part is insights and conclusion. We draw a directed graph to consist of book nodes. A points to B if user has read book A and also want to read book B. The Hunger Games, Harry Potter, and the Philosophy Stone, To Kill a Mockingbird are pretty popular, lying many people's to-read list. In conclusion, recommendation based on network analysis has better performance than content-based method. For future study, we hope to collect more data and do the cross-domain recommendation, such as recommending movies based on the user's reading habits. Thank you for listening.